Restart. Yeah, that shouldn't be too much of a hindrance. Yeah, that's what I said. I've been here since 2010. First one I've ever had. All right. So this problem actually is really, really easy. All you're doing is plugging the numbers into it and plugging it into a calculator. Yes. So because they're giving you the formula and they're giving you the values and they're actually asking you to find H, which is what it's already solved for. So we have H equals A is 7.9. Cosine W is 3 pi over 7. T is 5 minus C is 3 pi over 7. Now, here's one thing that I know some people were messing up when they were doing things. Whatever calculator you're using, make sure it's in radians mode. Unless the problem tells you it's degrees, assume it's radians. So make sure it's in radians mode because you'll get a different answer for each one. So you'll have a button on it. This one is just right here. It says radians of degrees. Depending on the calculator, depends on where that button is. So in this one, we've got what? 7.9. Actually, I'm just going to do this. I'll type it in. I'll put it back to it. So also, when you're typing it in, type the whole thing in at once, or find a calculator that allows you to do that. Because you don't want to round as you're doing it because it will change your answer. So just type the entire thing in just like it's written in Alex or in Desmos, and you'll get your answer. This one wanted you to round to the nearest hundredth, so the answer would be 5.93 or 4.93. Sorry. So that's all you're doing for that one.
Wait, so what do you think?
Yeah, so you want it in radians. It should have
Oh, that little sliding button right there.
Yeah. Just make sure it says rad. All right. Any questions with this one? Okay. This one's asking for the function. So unlike the last one where they gave you the function, this one's not giving you the function. So we have to go back to what we talked about, what is the sine and cosine and how they actually look and work. So in this case, it's a harmonic motion, so I know it's going to be either sine or cosine. So and we basically need to know what my A is. That's my amplitude. And we need to know what the period is if it's inside. So those are the two things that I'm looking for. I'm looking for my, well, three things. We need to figure out which function we're using, and then what the amplitude is and what the period is. How do you, what's the main difference between sine and cosine at the start? Right. So one starts at the peak, one starts in the middle. So the question is what's happening in this problem at 0? It tells you at time 0, it's at 0. So that means we will use sine. So we're going to use sine for this one. Oh, and actually, it's a t, not a x. And a d, not an h. Okay. All right. So now we have to figure out our amplitude. What's the amplitude for this problem? There's an amplitude of 8. So A is 8. That one's simple, quick and simple. Then it tells me my period is 4. Remember, period is 2 pi over b. Okay, that's how you find your period. So if I got a 4 there, b would equal pi over 2 to solve that. So my b is pi over 2, and then that's my answer. There's going to be a topic on the test. It's actually not the way this one's worded, but it's actually the exact same work. When they give you a graph and you have to figure out the equation, it's the exact same thing. You're literally looking for your amplitude and your period. So as soon as you can find those two, we can figure out the equation for it.
Why does it weaken by
The period, the formula is pi over 2 pi over b.
Yeah.
So if I solve this, I get 4b equals 2 pi divided by 4. So b equals pi over 2. So the fire alarm was somebody burnt a granola bar in the food pantry in the microwave. That was what the fire alarm was. I don't know.
science?
Warm it up, soften it up maybe. I don't know. All right, so that's it for that equation. Let me get another one of these. Let's do this one. All right, take a minute and try this one. Amplitude is, oh yeah, it's at time 0, yes, -3 feet. All right, so which function am I using for this one? Cosine. What's my amplitude? 3. My period's 8. So 8 equals 2 pi over b. So b equals, that's it.
I feel like we need a graph. Can you do a step by step developing B?
Give me back my problem. Yeah. Yes. Amplitude's always, oh, actually, yes, you're right. So it's, so, okay. So amplitude's always going to be positive. So is, in that case, the amplitude is still 3. It's going to be negative, you're right, because we have to flip it over because it's starting at the lowest point, not technically the highest point. So you're right there. So it's, yes, it should be -3. Yeah. So if cosine, because cosine always starts at the maximum point. If it really starts at the minimum point, you just flip it over, which is the negative, or the yeah. I can't, reflection. That's it. I'm like, I was trying to think of the R word that wasn't reciprocal. All right. Let's look at a very similar problem, but way more complicated. So we're still dealing with a spring. The only difference in this case is this problem is going to have some more shifting in that we're going to have to deal with. Okay. So they give me a couple pieces of information. They tell me my minimum point is at time 0 and it's 0.5. And my maximum point is at 1 and 5.5. So we're still going to do the same basic setup. I have to figure out what my function is going to be, and then I have to figure out the shifts for it. Okay. So if it's starting, this one's starting at the minimum value, so I'm going to use what? Cosine. Sine's always right in the middle. It's not the max in the min, it's literally right in the middle is where sine starts. Cosine will start at the minimum or maximum. Since it's the minimum, it's going to be the negative version of it. So I need to figure out A, we're using cosine, B of t plus C plus D. So I have to come up with all those letters now. We're going to actually get rid of that because I don't need it anymore. Okay. All right. So first thing I have to figure out is my amplitude, right? So in this problem, I'm going from a low point of 0.5 up to a high point of 5.5. Okay. So what's my amplitude? So if we split this in half, because remember, we're going from the lowest to the highest, right? And we only want half of that. So I'm going to subtract those two. So 5.5 minus 0.5 is 5. Divide that by 2, and I get 2.5. It's okay. That would have been 3. You were right there. All right, so I've got A. And it is going to be a negative because we started at the minimum value. All right, so now let's look for my period. From my minimum value to my maximum value is 1 second, right? So then from my maximum value back down to my minimum value is going to be another 1 second. So that means my period is 2 seconds. So 2 equals 2 pi over b. So that means my period is 2. My b is going to be just pi. So pi of t. Is this okay? So we've got those two. Any questions on those two? Those two make sense. It's basically the exact same thing I just did in lesson. Because so a 1 period is going from wherever it starts back to where it starts, right? So at the minimum where I was at 0, I got to a maximum at 1, because that's what the next point was, and then to go back to the minimum would be another 1 second. So to do 1 complete loop is 2 seconds. That's where the 2 comes from. All right. The C would be, where's that initial point? So in this case, my initial lowest point was at 0, right? So I'm not shifting horizontally. I don't have a phase shift in this problem. So C in this case is 0. So I don't have to worry about this. If the minimum point was not at 0, if it was shifted over, then I would have had to do a phase shift there. Okay. The D is vertical displacement. Remember that normally that middle line is where? The middle line in all your trig functions is at what for your parent functions? 0, the x-axis, right? My middle line's not at the x-axis in this case. My middle line is going to be where? It's going to be at 3. Because I have to go up 2.5 to get to that and down 2.5 to get to the lowest point. So my middle point is 3. So my vertical displacement is 3. We took the whole cosine function and shifted it up 3. So that's the final answer. In this problem, I think they actually asked you to graph it. So, but they actually asked you to graph it first. No, actually, this one they asked you to graph first. You're literally just going to put the points that they told you in. So you know your minimum points at 0.5, your maximum point's going to be at 5.51, and then it's going to be back to a minimum at 2, and then you know your middle point's at 3. So they just put a couple points there. And then you hit the little graph button. They actually, for this problem, they wanted you to model it first and then come up with the equation for it. All right. Questions with that? All right. So it's very similar to the last one. It's just we're adding in those shifts. So. All right. Next one. All right, so this question, they want you to graph it. So we're going to share this one. So they want you to graph this equation. So for cosine, your first point is going to be where? It'll be at 12, right? So we got that one. Okay, the rest of these I actually have to come up with. I have to do the parent function for this one. So this one we need to use the parent function for because they want all the points. 5 pi over 8, yeah. So cosine is 0 pi over 2 pi 3 pi over 2 and 2 pi. And then it is 1, 0, negative 1, 0, 1. So I'm going to multiply the y by 12. So I get 12, 0, negative 12, 0, 12. What am I multiplying the x by? 8 over 5 pi. Remember, we have to flip that over. So 0 is still going to be 0. All the rest of these, your pi's are going to end up canceling out. So because there's a pi on top, and now there's a pi on the bottom. So it's 8/5 times a half. So we've got 4/5, 8/5, 12/5, and 16/5. That's -12. So you graph those points, and you hit the graph curve. The next question says, find all times between 0 and 3 seconds when the weight is 8 centimeters above the resting position. So the resting position's at 0. So they want to know all the places where it's going to be 8 centimeters above that. So here's how I would do this one. You're going to use Desmos and graph it. So let me put the equation in here. Hold on, I need the equation. So graph it in Desmos like this. So you have y equals that. And then just put y equals 8. And we're looking for the values that's less than 3 seconds. So it's less than 3 seconds. We have 2 values because that one's over 3. So 0.428 and 2.772. And it said it wanted it to the nearest tenth. So 0.4 and 2.8. And if you look, that kind of makes sense based on the graphs that they gave you too. Oh, I have to use the OR button. So using Desmos, you can easily get those values out. And that's actually how it wants you to do it. It wanted you to actually use the graph to determine it anyway. So You're not cheating or anything else there. All right. Any questions with this one? Okay. So now we're going to go into right angle or right triangle stuff. So your right triangle stuff, this is all SOHCAHTOA. Okay. Whenever you're doing the SOHCAHTOA stuff, you need to look at where you're standing. Okay. Because depending on how the triangle's shifted, your opposites and your adjacents can change. It all is based on where you're standing. So in this problem right here, actually, I don't even need the actual problem. I literally just need the picture because they put everything in there. I can make this a little bigger. All right. So here's I'm just trying to make the house bigger so I can. There's my bigger house. So we're standing here. So this is my opposite. This is my adjacent, and that's my hypotenuse. Your hypotenuse is always across from you 90 degrees. Your opposite is always across from where you're standing, and the adjacent is next to where you're standing.
How do you know where you're standing?
They'll either tell you or where the angle is. So in this case, they gave you the 75 degrees in that little arc.
And
that's where we're standing.
That's why I was standing.
So if sometimes they'll tell you like you're looking for sign of A or sign of B or whatever it is, you're going to be standing at that letter. So your angles will always be capital letters. Your sides will always be small letters. All right. So if they tell you you're standing at sign of B, you're looking for the big B in the triangle. So I know there's some topics that have that in there as well. So, all right. So we've got this. So we're looking for our hypotenuse and we have our opposite. So which function? Sine. So it's going to be sine of the angle, 75 degrees. Now, this is degrees, so make sure your calculator is in degrees. Equals opposite, which is 15, over hypotenuse, which is x. Okay? When you're typing these into the computer, into the calculator to get your answer, just switch these two. So x equals 15 over sine of 75. Type that into your calculator to get your answer. And again, make sure you're in degrees.
Will they be different if you both in Desmos?
What do you mean?
Like, would it give you a different answer?
If you did it in radians? Or you can't type, you can't, because you have to have the letter by itself. So in essence, it's basically just it's the multiplication and division. The easiest way is just remember swap them.
Yeah.
So if the x is in the bottom, the sign's going on the bottom. If the x is on the top, it's just the sign stays on the top. You're multiplying. So if you did this in your calculator, you should get 15.53 if you round off to 2 decimal places. If you do not get 15.53, you did something wrong when you typed it into your calculator. I would highly suggest if you're having trouble to try this in your calculator, make sure you get the right answer. Because the number one mistake people make on this is not making sure your calculator is in degrees or radians and typing things in incorrectly. You do not want to try to do this in rounding things as you're doing it. That's why when you type into your calculator, you want to type the entire thing in as the 15 over sine of 75 so you get the answer exact of one shot. Okay. All right. Any questions with that one? Which one? Oh, yeah. There you go. All right. So most of these word problems are just going to come back down to which function you're using and making sure you have the right pieces. Yeah, actually, not that one. All right. This one. So planes ascending at an angle of 2% or 2 degrees from the horizontal. Again, they give you a picture, which makes your life a lot easier. So you're not having to draw the picture out for these. The plane's current altitude is 8.3 kilometers, which is right there. They want to find the new altitude after 0.2 hours. And they tell you that it's traveling at 400 kilometers per hour. So so I have three things. So actually, C, A, and B. Yeah, that's 8.3 kilometers. Which value do I need to find on my triangle? A, B, or C? I need A, right? So this is the one that I need. Because if I take that away from the 8.3, I'm going to get what's left. So in the triangle, I need A. Okay. To do this, I need two parts to my triangle. I need an angle, and I need at least a side. Okay, so I have the angle. The angle's 2%, but I don't have a side. They did give you some other information that allows you to figure out one of the sides. They told me they traveled 0.2 hours, and it's going 400 kilometers per hour. So how far is the plane traveled in that 0.2 kilometers or 0.2 hours? Yeah, so we're going to multiply that. Is it? Yeah. No. Yes, it is 80. You're right. 80 kilometers. Sorry. I'm doing like in my head a couple times. I'm like, wait, that doesn't sound right. Yes, that's right. All right. So 80 kilometers. Is that B or C? Which one of those two is the plane's path? C. That's the 80 kilometers. So that's 80 kilometers. Okay. If it said the linear distance that it traveled, then it would be B. Okay. So it's a matter of what is it? In this case, it's telling you it's traveling at 400 kilometers an hour. It's going to be whatever path the plane is taking, which is that diagonal path. So that's C. So we've got A and C for this one. So C is my what? C is my hypotenuse, and A is my opposite. So I'm going to use sine for this one. So I have sine of 2 degrees equals A over 80. So A is sine of 2 degrees times, actually, 80 times sine of 2. The nice thing about word problems is the answer should make sense. So if for some reason you screwed this up, the only ways you could possibly have screwed it up would be to have used cosine or divided instead of multiplying. Those are all the 4 different kinds of answers you could possibly get, as long as you did degrees correct, not use radians. Okay? Only one of those answers should make sense. They're 8.3 kilometers above the ground, right? So they couldn't have dropped 80 kilometers. They couldn't have dropped 2,292 kilometers. All right? None of those answers make sense. The only one that makes sense is the first one, which is the one that's correct, which is 2.79 kilometers.
75 to 80 kilometers per hour.
It was the 0.2 miles per hours times the speed. Okay. So when you're looking at your answer for a word problem, make sure the answer makes sense. If the answer doesn't make sense, go back and look what you did. And that could be a problem that you had. So in this case, they wanted it to the nearest tenth. So we'd go 2.8 kilometers, and we're not done actually with this problem. So A is 2.8 kilometers. They didn't want A. They wanted H. Oh, actually, yeah. They said not to round, and I rounded. That's okay. I don't think it's going to make a difference, but I'm going to find out. So 8.3. So what was it? 80 sine of 2. It doesn't change the answer for this one. So we're going to subtract the 8.3 and we're going to minus the 2.8 and we get 5.5. So that's how many kilometers above the ground they are. The other thing with word problems is make sure you're answering the question that they're asking. Okay, if you notice, there was 3 calculations we had to do for this problem to get the actual answer they were asking for. It is really easy to go, oh, I got 2.8, that's the answer. Okay, go back and read the question and make sure you're answering what they're asking. So, like when I'm making up multiple choice questions, I don't make multiple choice questions for you, but I had to do it for an AP book I was writing. Like those were the mistakes answers that I put in. So like for this one, 5.5 would have been the correct answer. One of the answers choices would have been 2.8. It's on purpose though. When they're doing those things, even the SAT does it. When they're doing those things, it's designed to catch mistakes. So that was designed to catch a mistake. All right. Any other questions with this one? I'm not doing, so there is a bunch of topics on that are just like this, that are just a triangle. It's like they give you a triangle, they're asking you for a side. I'm not doing those because in essence, it's the same thing as this. It's just a triangle. There's no word problem involved in it. So I'm kind of doing the word problem ones to show you how to do those problems.
There's one. Wait. It's literally just gives you a triangle H.
Yep.
And it just like has, I think that's the beginning of it.
Oh yeah, because it's just, it wants the letters.
Yeah.
Yeah. That's just to make sure you understand opposite adjacent hypotenuse. All right, so it says a plane is 138 miles north and 182 miles east of the airport. Find the X angle the pilot should turn in order to fly directly to the airport. All right, and I'm gonna make this the picture a little bigger, so we can see just because I just need the picture. There we go. All right, so we got our picture. This is all I need. Where am I standing? We're standing on the plane. As long as they don't have the seatbelt sign on, you're good. All right. What's the 138? That's opposite. 182. Adjacent. Which trig function am I using? Tangent. So it's tangent of x in this case, because I don't know that value, equals 138 over 182. Yes.
When do you know when to use regular tangent?
Right here, I'm going to show you right now. So if you noticed, I didn't ask that question on purpose. So whenever you're doing these problems, always set them up with the regular value. Okay. So like even with like these, we set it up. It's always the trig function times the angle equals whatever it is, opposite over adjacent, whatever else. Always set it up that way. Depending on where your x is, depending on what you're looking for, depends on how you're going to solve it. In these two problems, the letter was over here, so I can just multiply and solve it. And this one, the x is inside my tangent. I'm going to have to use the arctan or the inverse tan to find it. But I always set up the problem without that. So this way, your process is the same for every single problem. That's when you're going to use the arctan trick. Yeah. Arctan and tan -1 are the exact same thing, by the way. It's just easier for me to say arctan than tan -1. But they mean the exact same thing. You'll see it as, and depending on the calculator you use, so it could be written like that or like that. Those mean the exact same thing. Okay? So either one of those, if you see it, will do the same stuff. All right. So in this case, I'm looking for the x inside of my tangent function. So this is the one I'm going to have to use the tangent -1 button. So we go to Desmos. They have the tan -1 button there, so you do not have to type in the exponent of -1. Again, since my numbers, since they're looking for it as a degree, make sure your terms are in degrees. Most of your word problems that are dealing with triangles will be in degrees. Most of your word problems when they're dealing with the unit circle or those type of things, like the periodic chart thing, the unit circle stuff, it'll be in radians. Okay, that's really the difference between it. So all the stuff with just triangles will most times be in degrees. So in this case, that's the tan -1, 138 over 182, and it's 37.17 degrees. And I think they wanted this one to, I think most of these are to the 10th. Yeah, this one's to the 10th. So we'd have 37.2 degrees for this one. All right. Let's see if I can get another one of those. That's the final answer for that one.
You don't need to find H.
Nope. In this case, they just wanted that piece of information. They just wanted to know the degree or the angle that they have to turn at. All right. Let's do one more of these, and then we'll go into the more complicated ones. All right. Where am I standing? Oh, where am I standing? At X. Okay, so 7 or 15 is my what? That's my hypotenuse. 7 is my adjacent. So I have adjacent hypotenuse, so which function? Cosine. So cosine of X equals 7 over 15. I don't have it over there, so I don't really need it in this case. You could. They gave me my adjacent, my hypotenuse in this situation, so those are the ones I need anyway. I'm looking for the X inside of the cosine, so I'm going to use cosine -1. So we get 62.2 degrees. Is the angle at what the ladder is placed to the house.
So adjacent is always touching the angle you're looking for.
Yep, because it's next to it. So adjacent means next to, and opposite means opposite of it. So if it's touching it, it's next to me. All right. Let's look at the two next hard ones. So the next couple problems are more complicated purely because they have multiple triangles in them. Okay, so that's what makes this problem more complicated, is that it's asking for multiple things and there's a bunch of different triangles that are involved in it. All right, so it's looking for A, B, C, and D. Which one do you want to find first?
A.
All right. So we're standing here, right? So A is my opposite, B is adjacent, and 11 is my hypotenuse. So if we're looking for A, we're looking for the opposite, and I have my hypotenuse, right? So A is opposite and hypotenuse, so opposite and hypotenuse is which function? Sine. So sine of 22 equals A over 11. So A equals 11 times sine of 22. All right. So we can plug that in, get my answer. So we get 4 point, actually I think I wanted this one rounded to the nearest one, so 4.1. So A is 4.1. All right, find me B.
So are A and C the same size?
No. So how am I finding B? You could use the Pythagorean theorem. I would not. I would use cosine. So what a little pet peeve of mine, and it's nothing to do and you get the right answer either way. Try not to use something you found, if at all possible. So since we found the answer of 4.1, if I use it and that's wrong, B is automatically wrong. Okay? If I find B using cosine, I'm not using the 4.1 at all. I can actually use that to help me make sure that 4.1 is correct. Okay? So it's one of those things like if you screw up one, you might not screw up the other one, and you can use that as a help part there. So you could use the Pythagorean theorem, you would get the right answer. And actually, I think Alex tells you to use, or says you could use the Pythagorean theorem for this one. I would use cosine. So I would do the cosine of 22 equals B over 11. So it'd be B equals 11 cosine of 22. Which in this case is, which I didn't do, which I probably should have done beforehand asking you that question, is 10.2. So B is 10.2. Now, so how can we use this to figure out if I did my problems right? The smaller angle always goes towards, is opposite of the smallest side. 22 is going to be my smallest angle in this triangle, right? That's kind of got to be smallest. So if for some reason you screwed up your sines and cosines, you'd have gotten 10.2 here, and you'd go, oh, something is wrong here, when you got 4.1 for this one, and you'd have caught your mistake. Okay? So it's those little things that'll help you figure this stuff out. The word problem that I cut off at the top actually gives you one more piece of information, because as it stands right now, you cannot find C and D. We would need more information to be able to figure this out. It gives you one more piece of information. It tells you that A times C is 43. So now that I found A, I can use that information to find C. So I know that 4.1 times C equals 43. So C equals 43 divided by 4.1. And I get 10.5 for this one. And that's C. Huh? I didn't get D yet. I needed C before I could find D. Yes, I am going to use tangent for D. Which sides am I using, though? Oh, actually, we can't use tangent for D. Why can't I not use tangent for D? I have the opposite and I have the adjacent. I don't have the angle where I'm standing. Okay, because to find D, I need to look at this triangle. Yes, so this one I would use Pythagorean theorem for. Yeah. Because based on the information they gave me, there's no other way to figure this out without the Pythagorean theorem. So no. 10.2 squared, I have to add those together and I get 14.6. So it's 10.2 squared plus 14.6 squared. Yeah, this one's long. So I have 10.2 squared plus 14.6 squared equals D squared. It's 17.8. If they gave me this angle up here, I could have used tangent and stuff like that to find D. If they'd given me the angle over here, I could have used that as well. But as it sits, I don't have any other angle information, so I have to use Pythagorean theorem for that.
Is the Pythagorean theorem the only way?
Once you have two sides, you can always use Pythagorean theorem, as long as it's the right triangle. If it's not a right triangle, then I can't. All right. Next one. So a surveyor wants to know the length of a tunnel built through the mountain. According to equipment, she's located 54 meters from one entrance at an angle of 56 degrees to the perpendicular. and 31 meters from the other entrance at an angle of 13 degrees to the perpendicular. Based on these measurements, find the length of the entire tunnel. This is one of those problems that I guarantee you'd look at and go, yeah, no. This one's only going to take 2 calculations to find my answer. The key is look at them one at a time. Huh? It's not a 30, 60, 90. That would be nice. It's not. Just look at it one at a time. So let's look at just this triangle over here first. And we're going to find that length right there. So I'm standing at 56, right? X is my what? That's my opposite. And 54 is my hypotenuse. So that means I'm going to use what? Sine. So sine of 56 equals x over 54. So x is 54 times sine of 56. Now let's look at this triangle. I'm looking for y, right? The nice thing is it's the exact same thing, except it's sine of 13 now and 31. So sine of 13 equals x or y over 31. So y is 31 sine of 13. It said in here, there's a reason I didn't find the answer to those, because it says do not round your intermediate calculations. What am I doing to those two? I'm adding them. I'm going to type that entire thing right into Desmos and add it all in one shot. So 54 sine of 56 plus 31 sine of 13. So when you type it in, type the whole thing right in. And then you get your answer. So 51 points. They wanted it to the nearest 10. So 51.7. So I said, a lot of the word problems with these is they look insanely complicated. But once you break it down and look at the triangles, it makes it a lot easier. And like I said, they're always going to give you the picture. That helps a ton. It'd be a lot harder if I gave you the word problem and said, here, make me the table from this, or make me the picture from this. That'd be a lot more complicated. You could have, but that's almost 150 feet. Quite long. Yeah. Oh, no. In Alex, no. No, Alex is going to have you find it. These are Alex problems. They're not going to have you do it without a picture. So, like, for example, this is another problem that's very in the same topic. They want to know the difference in heights of the balloons. We would do it the same thing. We're looking for which values, though, in this case. We're looking for that value, and we're looking for that one. So I'm looking, in this case, that side is what? That's adjacent. And I have my hypotenuse. So which function am I going to use? Cosine. So cosine 42 equals x over 670. So x equals 670 cosine of 42. And then I have cosine of 36 equals y over 945. So y equals 945 cosine of 36. And then we're doing y minus x. So you can start to see like the process is basically the same.
This feels more right?
It is because it and this is why this is typically what's taught in high school. This will be either taught in your geometry class or your algebra 2 class, depending on where they stuff the trig. But this is basically what you learn in those classes. You do right angle trig, which is just this stuff. All right, I want to do one more problem because I know it's on the test. For some reason, I didn't copy it into there, and I don't know why. I think it was here. Hold on. I just got to find the picture. Maybe it's not. Actually, this one works. I'll do this one. All right, I'll show this one. All right, Lena's tracking her height above the ground on the Ferris wheel. Her height above the ground is h meters as a function of time. So this is basically how high she is above the ground on the Ferris wheel. What is the amplitude of the graph? You're welcome. So it starts at 2 and it goes to 12. Right, so the amplitude is 5. So which description best describes amplitude of the graph? The number of times she goes around the Ferris wheel, the number of meters from the center of the Ferris wheel to her maximum height, the number of meters from the center of Ferris wheel to the ground, or the number of seconds it takes Lena to make one revolution around the Ferris wheel. Yeah, it's from the center to her maximum height. It would be from the center to the ground if it was at 0. But since it's 2 meters above, it is not to the ground. Sure. So the amplitude is basically you're looking for the center line, and it's how far above the center line you are, or how far below the center line you are. So in this case, the other way you can think about it, since the center line is your average, just average the numbers. So your lowest is 2, your highest is 12. Take them, add them, divide by, or your middle line is going to be at 7. So my amplitude is 5 above that. Okay, does that make sense? Step 1, find the center. And then figure out how far above your center you are. You also can take the 2, subtract them, and divide by 2. That'll also give you 2. Because that'll tell you how far the distance between them is, which in this case is 10, half that's 5. It just depends on the direction you want to go. It depends on what information they're giving you. So, all right, next question. How many seconds does it take her to make one revolution around the Ferris wheel? 10. So from there to 10. How many full revolutions will she made after 40 seconds? 4, because everyone's 10.
I like it.
Huh? No. Actually, I don't know which one I put on there for. This one might be on there. The test is already online, so you can look at it. The chapter 6 review is already there. So, All right. Other than giving you more problems to try, we're done.
Thumbs up.